I have a weekend project here that I think might be fun to go over. This project is me experimenting with a few different things. One is Scala Native, which is the native compiler for the Scala language. Scala is the language I use for work and have used for work for quite some time. Pretty happy with the language. Sometimes I really do miss Haskell, but overall I'm generally really happy with it. For my weekend projects, I'd like to do some emulator type systems, and I figured now that Scala Native is getting fairly usable, I'd give that a shot. So what I have here is I'm just going to call it an emulation tool so far. The goal is to have a NES emulator that is very informative about what the Nintendo is doing, what instructions are being executed, what purpose blocks of code are meant to satisfy, and what the state of the system is, and ideally enable patching at runtime of the NES code that's being executed for experimentation. Right now, though, I'm just setting up the project and getting started. This is on GitLab, and I'll point a link down below for those that are interested, and you can see how this project is set up. What we're looking at here is the parser code for reading a NES version 1 ROM header from a file. NES version 1 ROM header consists of these fields, which are what they are named, and I've associated two other constant values with this type, which is the file type and extension. I intend to extend this tool to do info about other ROM types, not just NES, but maybe some others. NES, just going to focus on that for now. We can look at how it's being parsed, and this is a fairly standard parser. We have a sequence of parsing instructions here. First, we read off 4 bytes, check if that matches our magic hexadecimal header. And then we read off some other information, bytes that we transfer to an integer, and bytes that represent the flags, and we expand on those flags with some fairly simple operations to form our resulting header. Fairly straightforward stuff. This being Scala Native, some of the standard tools I use were not available for Scala Native, so I had to use some other stuff and build some other things on my own. Some things that were available that I thought were pretty darn slick is S-codec bits, which allowed me to build a very simple bit stream parser. And actually, it's entirely based off of the bit vector and byte vector type from S-codec bits. There are other parsers I could use, but again, they weren't really available for Scala Native, so I ended up building a tiny little parser off a bit vector, and I'm fairly happy with both the performance and the usability. I'm really happy with bit vector and byte vector usability. I haven't really checked the performance, but the resulting performance of this is fairly acceptable. And here is some Scala syntax that isn't supported out of the box, which is a type lambda. I don't know why it's not. I guess the encoding is rather strange, but fortunately, there is a pretty slick Scala plugin that enables you to do type lambdas. I'm going to say it's kind projector. Suddenly, I'm not so sure. I'm pretty sure it's kind projector, which is extremely useful in this regard. You notice I use this type a few different times. It saves me doing that little alias. And this resulting parser Works fine for my purposes so far. Pretty quick to specify and easy to use, so I'm happy with that. The other tool I'm using in here, or library I should say, that I'm using in here, which I'm really happy with, is Alex R. Chambolt's Case app. It's a pretty cool idea. I really like it. This has a very nice annotations and structure-based specification for your case app options. And here you can see some of them. And then our options are broken down into a sealed trait with case classes. So the other aspect which was quite useful for this was our shapeless library. And shapeless I use to actually output the, let's look at an output here. This structure here is both a mix of manually defined output structure, so I was free to do whatever there, and also automatically generated output commands using shapeless over the algebraic data type that represented this header. And you can see it did pretty good. I was fairly happy with this. This one is kind of interesting. I'm pretty sure this could be corrected in my code. In fact, all these oddities could be corrected where this is put on a new line and intuitively you'd suspect it onto in the same line. I think all of that could be corrected, but this was fairly quick to define. Took a bit to learn shapeless, but in the end I was pretty happy with how it ended up working. I did end up dispatching between two handlers of the structures to get two different styles of output. And that the library I use to build this, the module I use to build this, console PP, console pretty printer, is fairly separate from this code, so I will try to put it out on its own library. General idea is that you're able to define a type class, console PP, that defines the operations for printing to a console, and you're given an EDSL of base operations you can use to define the console pretty printing for a type. This is largely a wrapper around a color console printing, which is F-ANSI by Li Hao Yi. But it tracks indent level, and I'm using a standard reader-writer state monad to track that, which is the indent level, right to a vector of fancy strings. And, oh, actually, sorry, there is no state. Its indent level is the environment that's read from, which gives nice scoping effect to any changes in indent. So that's fairly standard. Wrap that in its own type called ops, alias some other stuff into the EDSL, and add some combinators for indent, outputting, pretty printing another console pretty printing type, and pretty printing generic. These are not made the same in case I want a mix of generic printing and specific printing. This seemed to work the best and prevented searching for this label generic representation coproduct for every pretty printing. Might be a better way to do that, but man, that was expensive. And having them separate matched my expectations of how to specify the two different behaviors I wanted. So anyways, all of the ones above are pretty straightforward. Pretty printing generic is the interesting one because it uses shapeless. This uses this construction, label generic aux, to infer the representation, the coproduct representation of some type, and infers the generic console pretty printing of that representation. This generic console pretty printing is very similar to console pretty printing, but it'll only apply to this coproduct. Anything that isn't a coproduct is dispatched to a different pretty printing type class that helps me keep the formatting nice. And then there's some base classes for just console pretty printing. And then I have my generic pretty printing, which handles records and coproducts and dispatches to these other definitions of pretty printing for those types. It ends up working fairly well. I don't have to define a huge amount of pretty printing code. I can define however much I want. So you can see here, this is pretty printing operations for the header. And you can see that the type is still header. It applies to all headers, but I've mixed both pretty printing generic of the header as well as some pretty printing specific to that type that I want. And in this case, all headers have these constants, file type, and extension that I want printed in a particular fashion. So I was pretty happy with that. Hoping to, like I said, get that open sourced, and I think that would be pretty fun. It's also worth mentioning this other tool, which is not a new one I use, but it's pretty much essential for Scala development. And that's CB372's Scala typed holes. Absolutely essential. That enables you to throw down ye old triple question mark, undefined nothing, and get back the inferred type, which is darn well useful because you can throw down ye old triple question mark in quite a few different places as you develop. And with your tilde file watching, it gives you a very nice incremental feedback on the expected types as you're compiling. So I hope to dig into that more, but it is but a weekend project, so it won't be until next weekend. I'll give you guys an update then. Later.